Hey Algebra 1, here are the notes for 8.8, special products. So what are we going to do to simplify or expand the expressions below? Well, we know that when something has an exponent, it means we're going to multiply something by itself as many times as that exponent tells us to. So I know that your gut reaction is to go ahead and distribute that 2 in. Please don't do that. That is not what this expression is telling us. What it's telling us is that we have to take x plus 2 and multiply it by itself. Let's do this both ways so you can see why that original method doesn't work. First, we're going to do it the right way, and that is by multiplying like this. So when we put it side by side, we're going to use our FOIL method that we learned in 8.7. We're going to do our first two terms, so that's x times x, which is x squared. Now we're going to do our I'm going to do the inner terms first just for the sake of my writing. So plus 2x. My outer terms, the x and the 2, so that's a plus 2x. And then my last term, so 2 and 2 is 4. So my final product, when I've done this the correct way, is going to be x squared plus 4x plus 4. This is good. However, now I want to show you the wrong way to do this. And I'm going to see if I think I have a red pen here if I'm not mistaken. There we go. So we're going to put it in red, so this is what not to do. So if I take x plus 2 and I just distribute that square in, I have completely ignored the fact that there is a plus symbol here. So when I do this, I'm going to get x squared plus, this is going to be 2 squared is 4. And I get x squared plus 4. But when I do this, I completely miss this term in the middle. I've ignored that term. So I cannot use this method. So I'm going to go ahead and take a big no sign through that. This is no. We cannot just distribute. I'm going to even put do not distribute over addition. It's fine if it's multiplication because we're multiplying everything at the end of the day, but in this case, because it is addition, that is a problem. So again, let's look at this. We're not just going to distribute that in. That is a no-go. We have to put these two sets of parentheses right next to each other and FOIL. So let's do that. FOIL says 2x times 2x is going to be 4x squared. The 2x times the 1 is going to be plus 2x. The inside is 1 times 2x. That's plus 2x. And then finally, a 1 and a 1, when we do our last terms, is just a positive 1. Simplify this down as far as you can. And this is what you get. Notice, the first term is something squared. And the last term is something squared. And the thing in the middle is going to be 2 of the first thing times the last thing. This is something that doesn't make much sense right now. I know I said a lot of things in that sentence, but this will help us later in our math career. So this is just something to look at, something to recognize. All right, let's keep going. Let's see another example of this. 3a plus 4 times 3a plus 4. That's what this square does, is it puts it in this term and it puts it in that term. It does not let us distribute. No. All right, so 3a times 3a is going to be 9a squared. 3a times 4 is going to be plus 12a. Notice, because we're doing the same thing with the outside terms that we're doing with the inside terms, we're just going to have that thing 2 times. And then finally, our last terms, 4 and 4 is 16. Notice, this is all of this squared. This is all of my c terms squared. And notice there's 2 of my a and my c hanging out in the middle here. So again, coming back to this equation, my final answer ends up being 9a squared plus 24a, that's my 2a, c, plus 16, that's my c squared, and my final answer. And we can do this with any type of equation, so I'm going to keep going. These ones I'm not going to explain. However, I would like you to pause the video if you're working through these right now and try these 3 examples on your own. Once you've done that, you can unpause the video and come on back to see if you've done them right. All right, hopefully you paused the video long enough to give these a try on your own. Now I'm going to show you my work. So a minus 3 multiplied by a minus 3. A times a is a squared. A times negative 3 is negative 3a. Negative 3 times a is negative 3a. And then negative 3 times negative 3 is a positive 9. Simplify down one step, and I get that. All right, let's see another one. 5y minus 2 times 5y minus 2. 5y times 5y is 25y squared. 5y times negative 2 is negative 10y. Negative 2 times 5y is negative 10y. Negative 2 times negative 2 is positive 4. Final answer at the end of the day, when I simplify these 2 middle ones, and negative 10 minus 10 becomes negative 20y plus 4. Again, notice we're going back to this idea. I'm always going to have an a squared, a 2ac, and a c squared. All right, one more here. 3x minus 3 times 3x minus 3. That's 9x squared. 3 times negative 3 is going to be negative 9. However, since I know I'm doing it again, I'm going to skip one step, see if you can follow me on this. Because I know I'm going to have 2 of these negative 9x's, I'm going to do negative 18x. That's this step in the middle. I have 2 of them. I just combined them into one step. If you didn't get that, don't go that fast. It's fine. Totally understand. Just thought I'd give you a little challenge to see if you could follow me on that last term. All right, here's our final answer. And because I just want to keep coming back to this idea, just so you see it again and again and again, if you have something that looks like this, I'm going to say this is challenge idea to see if you can pick up. If I have a plus c squared, my result is going to be a squared plus 2ac plus c squared. The only difference when I have a subtraction in the middle is then I'm going to have minus 2ac plus c squared. See if you can figure out why this is. Do a little trial and error with that and see if you can figure out why these equations are always true. All right, if you have any questions, let me know.